Okay, so we're going to get into the properties of what are called special parallelograms. And we have three special parallelograms. We have a rectangle, and what makes a rectangle is it's a parallelogram that has four right angles. Actually, this part of the word means right in German, and angle. So this is like right angle is actually in the name of the word, rectangle. And the second type that we're going to have is going to be a rhombus. And a rhombus is focused on the sides. It has four congruent sides. Gets me a rhombus. And if the two parents, the rectangle and the rhombus, had a baby, they would be a square. And a square has four congruent sides and four right angles. Okay, so there's a sense of inheritance here. All of these are parallelograms, so whatever is a property of a parallelogram belongs to all of them. These are rectangles, these are rhombuses, so they're going to have properties unto themselves, and the square will have the properties of both rectangles and rhombuses. Okay, so let's look at what some of those properties are. Okay, so the first property actually belongs to the rectangle. Okay, so what we're going to say here is that if I have a rectangle, then the two diagonals, that one and that one, so we're going to call this A, B, C, and D, and we're going to say that segment AD is congruent to segment BC. Now, how can I show that? Okay, so let's do some thinking here. This is a rectangle with those two diagonals. Because it's a parallelogram, AB and CD have to be congruent. The opposite sides have to be congruent. Because they're a rectangle, that has to be a right angle, and so does that. Which means those angles are also congruent. Okay. And then finally, AC is congruent to itself. All right, so why did I do all that? Well, I'm going to build two triangles here. I have a triangle ABC, which is this red one here, right? And I'm now going to have a triangle ADC, which is this blue one there. So these things overlap. Now if you look real carefully here, this is in the red triangle, this is in the blue one. That's a side. This is in the red triangle, this is in the blue one. That's an angle. And this is a side in both triangles. It's both red and blue. You can kind of see the colors there. So that gives me side, angle, side in the red triangle is congruent to side, angle, side in the blue triangle. That means that triangle BAC has to be congruent to triangle DCA by side, angle, side. Okay, now if you look, BC is in the red triangle. That has to be congruent to AD, which is the same side but in the blue triangle. That's by CPCTC, which means that in fact the diagonals of the rectangle, as we conjectured, must be congruent. So there we go. There's one of my properties of a rectangle, that their diagonals have to be congruent in a rectangle. Okay. Well, that was kind of fun. What about a rhombus? Okay. So let's get a property for a rhombus here. Let's say I have a rhombus. Let's call it A, B, C, D. And then I draw in its diagonals. Now they're definitely not the same length, but it looks like they might just be making a right angle there. So we're going to get rid of that for the moment until we can prove it. But we want to suggest that that segment AC is perpendicular to BD. So we're going to call that point in the middle M. All right, so what do? We have this rhombus, and its diagonals are AC and BD. We know that all of these sides are congruent. So we know that AB has to be congruent to BC, and AD has to be congruent to CD. Okay. Now, point B and D lie on the perpendicular bisector of AC. Okay. How do we know this? Right. So this is an interesting question. If I have a point and it's equidistant from the endpoints of a segment, then it must be on the perpendicular bisector of that segment. Now, lo and behold, we just showed that these two lines then must be perpendicular. That's it. So the diagonals of a rhombus are perpendicular. They form a 90-degree angle. All right, so that's awesome. All right, so let's see what else we got. Okay, so this is another little tricky bit here. So this is going to be about a rhombus again. Okay, and we're also going to talk about the diagonals. Okay, and we're only really concerned about the diagonal. Let's say this is A, B, C, D. We're only really concerned about this one, right? We could take either diagonal, it doesn't matter. And we're going to say that when the diagonal goes across, it actually bisects both angles. Okay, so we're going to say each diagonal bisects two angles. So what do I want to show? I want to show that BD bisects angle ABC and angle ADC. Okay, so I'm going to take a minute here and I'm actually going to clean that up a little bit. Okay, and I'm actually going to redraw it because we've done a lot here. So let's go ahead and redraw that thing so that we don't have some of the early clutter on there. So this is A, B, C, D, and I'm going to drop in that bisect, or that diagonal again. Now, the other thing that I'm going to do here is I'm going to be a little clever about this. All right, so let's see what we know. We know that these four sides are all congruent because it's a rhombus. And lo and behold, we know that that diagonal is congruent to itself, which means that triangle, let's call it BAD, has to be congruent to triangle BCA, or BCD. So the top triangle then has to be congruent to the bottom one by SSS. Well, what does that mean? Well, the corresponding parts are that angle has to be congruent to that one. So angle ABC has to be congruent to angle, CBA, and angle ADC, or ADB. Wait a minute. That's where I'm getting confused. Let's fix that. Lots of stuff going on here. ABD, there we go, has to be congruent to angle DBC, and angle ADB has to be congruent to angle CDB, right? So this has to be congruent to that, and this has to be congruent to that. This is all by CPCTC, which means that, well, if I'm going straight through and I'm breaking it into two equal parts, I think that means that this segment BD actually bisects these two angles, ABC and angle ADC. Well, there you have it. Okay, so we got three properties here. One, that the diagonals of a rectangle are congruent. Two, that the diagonals of a rhombus are perpendicular. And three, that the diagonals of the rhombus bisect two angles of the rhombus. And that can be either that diagonal, or you could do that with AC. It's going to work out the same way.